This is number 10 under 2D motion projectiles. We did this one in class. It's a bullet being fired with a gun held completely horizontal to the ground in a deer stand that's 20 meters high. I want to know the initial horizontal and vertical velocities. Because it's a horizontal problem, all at 500 meters per second will be x component, and there was no y component of the vertical velocity. I don't know, how long will the bullet be in the air for, and how long away will it land? C, D, and E are theoretical questions. So this is still a horizontal projectile problem like this. The initial velocity is 500 meters per second straight out, and eventually the bullet will hit the ground since he misses any targets or trees. Remember that the acceleration in the y direction for a projectile problem is negative 9.8 meters per second squared. And this is 20 meters, which means that the dy displacement in the y is negative 20 meters. Okay, I got my Vx. So to start with, again, go back and look at the key for number 8. Picture. Remember this from the beginning. The initial velocity for this kind of problem is all x, so there is no y. And then as it goes on, the y velocity gets bigger by 9.8 meters per second every second. But to start off with, there's no initial in the y. So for all these horizontal projectile problems, the initial x is what was given, 500 meters per second. And the initial in the y is 0 because it's horizontal. So that's what I've got asterisk. Part A, if the hunter misses the target, how long will the ball be in the air for, or the bullet? So part A, I'm looking for the time. Both the dy and the acceleration should be negative. That's because those are going to cancel out. Otherwise, if you forget to do the negative 20, you're going to get an error in your calculator because it's going to try to take the square root of a negative number. 2 times minus 20 over minus 20. And so the time that it's in the air for is 2.02 seconds. Part B wants to know how far away on the ground from the base of the tree does it land. That is this distance here, and we call that dx. So the equation for dx, we can go ahead and use the easier one since we already have the time. 100. And another way to say that is its range. That's dx or range. For part C, it says, what if the hunter chooses another gun that fires at a higher speed? How is that going to affect the time it takes for the bolt to fall? And it will make no difference. Remember the stuff from inside the demos in class. It doesn't matter how fast it's going here. It can be dropped. It can be going fast. It can be going really fast. But the time it takes to fall from this height down is going to be the same. So same time. Also, you can look at the equation for t. Notice there is no Vx in there. Vx doesn't change the t. For d, how would the range be different? If the time's the same, but my speed is faster, the range would go further. That makes more sense. If I fire it faster, it's going to end up further over here. So the range would be further. And then E says, well, what happens if instead he accidentally drops a bullet from the same height? How long will it take to hit the ground? And it doesn't matter if it's dropped or fired, the time is always going to be the same.